So this exercise related to momentum, you have already solved this. Just a quick revision. For a revision, I'm revising this. Question 22, I have recorded. Question 23. In the question, it is thought that an asteroid on a collision course with the Earth could be deflected by making a fast-moving spacecraft collide with it when it is still very far. So using this, we can collide with the asteroid and we can change its trajectory, the path. To test this idea, there are plans to send a spacecraft DART to collide with a small asteroid. After the collision, the DART and the asteroid will stick together. The DART will have a relative speed of 6,250 meters per second when it collides with the asteroid. This is expected to cause a change in asteroid velocity of zero point 0.4 millimeter per second. So that is a change in the asteroid velocity because of the collision. Show that the mass of asteroid is about 5 exponent 9 kilogram and mass of a dart is only 300 kg. So first, whenever objects are colliding, we can use a concept that whenever objects are colliding, they will have the same impulse. Impulse means the change in momentum, like the impulse of asteroid or change in momentum of asteroid and the change in momentum of the dart will be same. Or the same idea, if something is losing its momentum, the other one will gain the same amount of the momentum. That is also we can use a conservation of the momentum. So first the dart is there having a mass of 300 kg and it is moving at this speed. So what is the initial momentum of the dart? The mass is 300 and moving at a speed of 6,250. So when we multiply, we'll get the momentum of the dart. Three hundred times 6,250. What is the answer for this? Yeah, what's the answer for this? 1.87 into 10 to the power 6. So this is the momentum of the dart. Okay. Let's say it's collide with an asteroid. When it collide with an asteroid, they stick together and move. So already the asteroid was moving. Okay. And then what will happen? It gained this momentum and it continue to. This is the additional momentum which the asteroid will gain. Like this will be a change in the momentum for the asteroid. As we are using a conservation of momentum, the momentum before collision should be equals to momentum after collision. And we want to show that the mass of asteroid is about this value. And in the question, they specify the asteroid will stick together. So means when they're moving now, they stick together and moving together. I can also use this formula. I can use m1u1 plus m2u2 is equals to m1v1 plus m2v2. This formula could also be used like conservation of momentum. We don't know the initial momentum for this, but we know the change. Like this formula directly it cannot be used in this scenario as we don't know the initial momentum of the asteroid. So what did here that the change in the momentum, like how much the momentum changes for the dart, that will be equals to gain in momentum for the how much momentum changes for a dart, that will be equals to gain in momentum for the asteroid and the dart. Like that will be the final momentum as they stick together. So this is a momentum of the dart we calculated. Then the change in the momentum for asteroid, this value will also be the change in momentum because the dart hit the asteroid. So how much like momentum change for asteroid, that it will be equals to this value. It was having certain momentum, but as it collide, this is the additional momentum which it will get. And the change in the velocity as well, as you can see, this causes the change in velocity of asteroid 2.4 millimeter per second. So this is a additional momentum which the asteroid gain. This is a change in the velocity for an asteroid. So we can say the momentum of asteroid is a mass of asteroid, like the change in momentum of asteroid is a mass of asteroid multiplied by change in velocity. So the change in momentum of asteroid, how much it gained the momentum? It gained the momentum of 1.87 into 10 to the power 6. And because of this gain in momentum, how much velocity changes, the change in the velocity for asteroid, that is 0.4 into 10 to the power minus 3. So this is multiplied, other side it will be divided. So 1.87 into 10 to the power 6 divided by 0.4 into 10 to the power minus 3 will know what is the mass of the asteroid, which is 4.6 exponent 9. 4.68 into 10 to the power 9 kilogram. That's the mass of asteroid. So why they were not able to use the concept of momentum before equals to momentum after? Even this is actually the same concept, but we were not having the initial momentum. So what we did, like the asteroid was moving with initial momentum p, and when the dart hit, it has a momentum p2. What is the change in momentum? How much the momentum change is because the dart is collided and stick. So the change in momentum will be equals to the change in momentum of the dart or momentum of the dart. And then using this concept, the change in momentum and the change in velocity, we can work out what is the mass of this asteroid. So this is a case, it's applicable only when the two objects collide with each other and stick together. Then you can use this way that the momentum or the change in momentum of or the momentum of the first object, if we don't know the initial momentum of the second object, we can use this formal way to work out the mass of the second object. The next question, suppose that the dart collide with 90-degree direction to the asteroid. So let's say the asteroid is moving in this way and the dart is colliding 90-degree. And the asteroid orbiting at a speed of 0.16 meters per second about a large partner means the orbital speed of the asteroid is 0.16 meters per second. Calculate the angle through which the velocity of asteroid is deflected. So we want to calculate at what angle the velocity is deflected. The dart was moving in this way. As you can see, like both are 90-degree. And what is the velocity of the dart? 3 kilogram, 6,250. And then it caused a change in the velocity. So the new velocity is 0.4. And we want to calculate the angle through which the velocity of asteroid is deflected. So this was moving at the speed of 6,250 meters per second. And the velocity of asteroid has changes because when two object like this object is moving, it collided. So what will the resultant velocity? The resultant velocity will be in this direction because this is a higher value, this is a smaller value, but it's about the momentum. So this will be the resultant velocity. We need the angle between them. So we make a triangle, right angle triangle, and we'll use a tangent theta, which is a perpendicular divided by base. So this is 0.16 is there, meters per second. And the velocity has changed by 0.0, like 0.4 millimeter per second was there. So 0.4 into 10 to the power minus 3. The change in the velocity, so I should write it here. That is 0.4 into 10 to the power minus 3 meters per second. We need theta, like how much the velocity has changed from the original. So this theta is needed. How to draw vector? It's the same idea. It's not about vector of the momentum. It's about the vectors. Like it's not only related to momentum. It's just a simple vector diagram is there. Vector diagram, according to the figure, as I mentioned, the dart is colliding at an angle of 90. But what we want, the asteroid is orbiting at a speed of 0.16 about a large partner. We need an angle through which the velocity of asteroid is deflected. Like how much, by what angle the velocity has changed for an asteroid. That is what we need. We need this theta. So this was 0.16 and the velocity of asteroid has changes as is given in the beginning of the question by zero point 0.4 millimeter per second or zero point 0.4 exponent minus 3. So this will be a theta. So if we need theta, so it will be tangent theta is a perpendicular divided by base. So what is a perpendicular? Opposite to angle, we have perpendicular. So it is 0.4 into 10 to the power minus 3 and the base is 0.16. Then take a tan inverse. So theta is equals to tan inverse. What's the answer here? Or 0.4 into 10 to the power minus 3 divided by 0.16. 0.14. So 0.14, that's a change in the angle degrees. So it's a very small change in the angle. So next session we'll do from different topic. We'll do the question.